This is not a sound effect. This is the sound of Saturn captured by the Cassini spacecraft. In 1980, NASA's Voyager spacecraft flew past Saturn and sent back something nobody expected. At the North Pole, a hexagon, a perfect six-sided geometric shape carved into the clouds, each side longer than the diameter of Earth. 4 Earths could fit inside the whole thing, and it was just sitting there, rotating with the planet, stable, precise. Scientists thought the cameras were broken. They weren't. Nothing like this exists anywhere else in the solar system, not on Jupiter, which is twice Saturn's size. And here's what makes it genuinely unsettling. That hexagon has not changed in over 40 years of observation. Same shape, same size, same position. In a planet made entirely of gas, where nothing is solid, where storms rage for centuries, something is drawing a perfect hexagon and holding it there. The question is what? And the answer is stranger than the shape itself. The hexagon is made of wind. There's a jet stream flowing around Saturn's North Pole, a river of air moving at over 320 kilometers per hour. On Earth, the strongest hurricane winds barely reach 300. Saturn's jet stream moves at that speed constantly, without ever stopping. And instead of flowing in a circle the way every other jet stream in the solar system does, this one bends. It wobbles into exactly 6 waves, 6 peaks, 6 sides. The physics behind it involves something called a standing Rossby wave, a pattern that locks into place when a fast jet stream sits at exactly the right latitude, moving at exactly the right speed, on a planet spinning at exactly the right rate. Change any one of those variables enough, and the wave collapses. The hexagon disappears. You get a circle or chaos. Saturn has maintained those exact conditions for longer than human civilization has existed. Scientists recreated this in a lab using a spinning tank of water. The hexagon appeared on its own. The math works. But here's what the math doesn't explain. Why those conditions are so perfectly maintained. Why does nothing disrupt them? Why has this one specific configuration held for decades on a gas planet with no solid structure to anchor it? Inside that hexagon, at the very center of Saturn's North Pole, sits a storm. Its eye is 2,000 kilometers wide, larger than the entire continental United States. Wind speeds around the eye exceed 530 kilometers per hour. It hasn't moved in 40 years. A permanent storm, locked inside a permanent hexagon on a planet made of gas. If that doesn't bother you, keep going, because the rings are worse. Saturn's rings stretch nearly 300,000 kilometers from the planet, almost the distance from Earth to the Moon. They're made of ice and rock, ranging from particles smaller than sand to chunks the size of mountains. The rings are young. Scientists estimate they formed somewhere between 100 and 400 million years ago, recent by cosmic standards. For the first 4 billion years of Saturn's existence, it had no rings like these, or none at all. And they're already dying. Ring material rains into Saturn's atmosphere right now at roughly 10,000 kilograms per second. Ice particles, charged by sunlight, are pulled in by Saturn's magnetic field, falling and burning up in the atmosphere below. At that rate, the rings have at most 100 million years left. In a universe 13.8 billion years old, that's a rounding error. You are alive during the only window in Saturn's entire history, 4.5 billion years, when its rings are fully formed and visible. Before you, no rings. The odds of any civilization evolving during this window are extraordinarily small. And yet here we are. Where did the rings come from? Scientists believe a moon drifted too close to Saturn and crossed what's called the Roche limit, the invisible boundary where a planet's gravity becomes strong enough to tear an object apart. The moon was shredded. Its debris spread into a ring. Something had to die to make Saturn beautiful, and that beauty is already leaving. Now go deeper, past the rings, into the planet itself. Saturn has no surface. There is no ground, no place to land. If you descended into Saturn's atmosphere, the air would get thicker and hotter until the pressure crushed you long before you reached anything solid. Go deeper still, and something remarkable happens. The pressure becomes so extreme that hydrogen, the gas that makes up most of Saturn, stops behaving like a gas. It transforms into a liquid that conducts electricity like metal. This is called metallic hydrogen, and it exists nowhere naturally on Earth. The churning of this liquid metal is what generates Saturn's magnetic field, the invisible force that stretches millions of kilometers into space. At the very center, there should be a rocky core. Should be. Cassini's gravity measurements told a different story. The core appears to be fuzzy, not a clean, solid ball, but a blurred region where different types of matter blend into each other gradually. A planet 95 times heavier than Earth, and we cannot identify its center with certainty. We know more about the surface of the moon than we know about what's inside Saturn. Saturn shouldn't be this big. Planets form from clouds of gas and dust surrounding young stars. That cloud has a limited lifespan. The star's radiation eventually blows it away. Jupiter formed first and fastest, being the largest. Saturn should have taken longer, but the models say the cloud would have dispersed before Saturn could accumulate enough material to reach its current mass. 95 times the mass of Earth. A planet that, by our best calculations, shouldn't have had enough time or material to get that big. Either our models of planet formation are wrong, or Jupiter's gravity helped funnel material towards Saturn faster than expected, or something else happened that we haven't identified yet. Every answer opens a new question. Every measurement reveals a new gap in our understanding. That is Saturn's real horror. In September 2017, NASA's Cassini spacecraft ran out of fuel. After 13 years orbiting Saturn, 294 orbits, 453,000 photographs, enough data to keep scientists busy for decades, it had nothing left. The decision was made to destroy it, not because it stopped working, but because if left to drift, it might eventually crash into Enceladus or Titan, Saturn's moons that might harbor life, and contaminate them with Earth microbes. So they aimed it at Saturn and let it fall. On September 15, 2017, Cassini entered Saturn's atmosphere at 113,000 kilometers per hour. In the final minutes, it was still transmitting, measuring the composition of the upper atmosphere, sending back data nobody had ever collected, right up until the signal cut out. The scientists in mission control were crying. That data Cassini sent in its final moments is still being analyzed today. A spacecraft dying for science, teaching us until the last second. Saturn absorbed it without a trace. The hexagon kept spinning. The rings kept falling. The storm kept churning. Here is what 45 years of studying Saturn has taught us. The hexagon exists because of physics we understand, but persists in ways we can't fully explain. The rings formed recently are disappearing now, and we exist during the only window they're visible. The interior transitions through states of matter that don't exist naturally on Earth. The planet itself is larger than our formation models say it should be. Saturn is not a solved problem. It is an open wound in our understanding of how planets work, and Cassini, our best instrument, our most advanced explorer, spent 13 years there and came back with more questions than answers.
And then, in Cassini's final orbit, plunging into Saturn, measuring the composition of Saturn's atmosphere, sending back science till the very last second. We'll continue to learn from Cassini long after the end of the mission.
The next mission to Saturn is still in the planning stages, decades away from launch, decades more before it arrives. The hexagon will still be spinning when it gets there. The rings won't. Whatever we send next will see a different Saturn than Cassini did, slightly less ringed, slightly further along its quiet march toward being just another gas planet in the dark. We are in a window, a narrow, specific, unrepeatable window, where Saturn looks the way it looks. The universe doesn't wait, and neither should your curiosity.